we will be having the partial differential equations and its applications. Of course, like I've shown you last time, that it has several applications. It can be applied to heat conduction, wave propagation, and potential theory. However, for chemical engineering applications and chemical engineering advanced mathematics, we will only be dealing with the heat conduction. Kasi the others would be more appropriate for electronics engineering, electrical engineering, something like that. This one for physics and also for computer and ECEs. Okay, so as I think I've shown this to you last time, right? These are examples of the Laplace, the wave, and the heat equation. We're in this one. We'll be focusing on this one. And then I've shown you the three cases. Am I correct? Ito, just brush through with this kasi we need this for the next topic. Okay? So some assumptions are that u, or that the temperature that we would want to solve, is a function of x and t, where x is a function of distance and t is a function of time. So I've shown this to you last time. The first case, wherein the beta squared is equal to 0. The second case, beta squared is greater than 0. So you'll have this solution. It's easy for us. And the last case, wherein beta squared is less than 0. This one would give you an m squared is negative. So you'll have an imaginary. So you'll need to recall your Euler's form. So it would give you this solution. Okay. And we'll be going to the applications now. This one, let's just say we have a rectangular slab. The problem is actually in here in the next page naman. So let's just say here, we have a rectangular slab and then it has dimensions here. You can see on the Cartesian plane, this is a distance and then y is 0. That's 0 distance in a, and then b is 0. So it has dimensions of a, b, diba? A by b. So the u here are temperatures. You can see here that at the bottom, it is subjected to a temperature of 0. On the sides, the slab is subjected to a temperature of 0. And then lastly, you can see here that as you go higher and higher, this one, this end, is subjected to a temperature of u is equal to function of x. So what are the boundary conditions? First, as x approaches 0 from the right, u is equal to 0. U is equal to 0 from y is greater than 0 up to less than b. And then as x approaches a from the left, so ito, itong kabilang side, u is also equal to 0 when y is 0 to b. So that means yung buong ito, naka-0 siya. Itong buong ito, naka-0 siya, buong left side. As y approaches 0 from the positive, so ito yung base, it is equal to 0 daw. Tama? When y is from 0 to a, actually that's actually not y, it should be x pala. X should be 0 to a. Ito, yung base niya. Pero, when y approaches b from the lower side, so the top, u is a function of x. From 0 up to a. So, from left to right. So, what are the boundary conditions given? From here, alam natin na to. But we can rewrite this in a simpler way. So, you can say that the temperature 0y is 0. A, y, so a at any y is 0. Diba? X at y equals 0, so the base is 0, but x at y equals b is a function of x. And then it's given to be 10. So let the solution be u is equal to xy. But to take note that in this case, two-dimensional lang siya. Diba? Remember this equation? Second partial of u with respect to x, second partial of u with respect to y, second partial with respect to z. This is for three-dimensional problem. For us, it's two dimensions only, x and y. So that means it's just x and y, so you can cancel out the z. So let u is equal to xy. That means second partial with respect to x is x double prime times y. And then second partial with respect to y, x y double prime is equal to 0. And then isn't it that last time I said, in this case, it should be variable separable. So if it's variable separable, separate all the x's, all the y's, you'll end up having x double prime over x, y double prime over y, but then that's negative. It should be a constant. And then what's that constant? It is beta squared. So what's the next? Now that you have this, we will apply the three cases. So let's do the first case. M equals 0 twice kasi beta squared equals 0. And then here, y, m, kasi here, take note, y double prime over negative y. So that means I did not write it anymore. But then if you would want to write, it becomes y double prime over y equals 0. Negative y equals 0. And then negative y transpose it to the other side. It's y double prime equals 0. Or when you change that into m, m squared equals 0. Also twice. So I can see here that if u is a function of xy, it just becomes c1 plus c2x, c3 plus c4y. Wala na palang problem. Because the left side is basically c1 plus c2x. The right side is basically c3 plus c4y. Now, let's call this equation number 1. We apply the boundary condition. So 0, y equals 0. So I can say 0 is equal to c1, dahil ito mag-0 to times c3 plus c4y. So in this case, if I let c1 be equal to 0, c4y plus c3 should not be 0. Bakit? Because y is a constant greater than 0 and less than b. Now, I can see here that my final conclusion, ito, pwede ko na sabihin na, if my C1 pwedeng mag-0, ito yun, nakita nyo to guys. If yung C1 natin pwede mag-0, ito alam natin bawal mag-0. So we let that C1, kasi di ba ito, look, if 0 is equal to C1 plus this, pag yung C1 pwede nating mag-0, that means magsi-0 itong buong equation na to. Do you understand, guys? That if C1 in here is 0, the whole line will be equal to 0. Kasi parang dito, you're just proving that C3 plus C4y can never be 0. Why can it not be 0? Because y is never 0. Okay. So that means, kung yung C1 natin 0, look back at equation 1, matitira C2x na lang siya. Edi, yung equation natin could be reduced to C2x, C3 plus C4y. Let's call it equation number 2. Now, may iba pa bang boundary conditions? Let's see. Di ba ito na yun? May isang boundary condition tayo that x0 is 0. So, if yung y mo raw 0, kasi ako lagi pina-plug in ko, guys, look at all the boundary conditions in here. Pina-plug in ko yung may mga 0 muna, mas madali, as opposed to yung letter A, letter B. So if I plug that in, ito, that means yung y ko 0, ito, magzi-0 tong term na to. So I'm left with C2x times C3. In the product of this one, etong C3 ang ginawa kong 0. Bakit? Kasi yung C2 times x, which is actually kanina, nandito siya. Di ba yung C1 yung nag-0 natin? Eto, hindi pwede mag-0 yung x kasi bakit? Unless yung C2 mo 0. Pero the product of C2 times x cannot be 0 because x should be greater than 0 but less than a. Kasi di ba nakalagay dun sa limits natin, if you go back, 0 positive from the right side, A negative. So from the left side of A, hindi siya pwede maging equal na equal mismo. Okay. So going back, if C2x cannot be 0, yung C3 lang yung pwede natin maging 0. Okay. And then go back to equation number 2. Pag nag-0 yung C3, mangyayari C2x times C4y. Ayun, no? But isn't it that C2 and C4 are both constants? Right? So if C2 and C4 are both constants, let's just call it isang constant. Let's just call it C5. But then the thing is, if we apply the other boundary condition, A times Y equals 0, edi gawin natin A, yung X natin. So A, C5Y equals 0. Para mag-0, yung C5 natin, i-equate natin sa 0. In this case, yung A natin, alam natin bawal 0. Kasi yung A natin is any value greater than 0 for X. Yung Y naman natin later on, pag nakita mo, any value greater than 0 less than B. So ito, the only thing that can be 0 is C5. Pero may problema tayo, guys. Pag yung C5 mo 0, look back at number 3. 0 times XY, edi 0 na lang lagi ito. So the U, XY is 0. Ang tawag sa kanya, trivial solution kasi wala tayong masasolve eh. Kahit ano mangyari pala dito, using case number 1, magsi-0 lang talaga siya. Eh di wala kang masasolve. Kasi most likely, my question will be, give me the expression in finding the temperature at any time t. Di ba? Eh kung laging 0, eh di wala tayong na-solve. So punta tayo ngayon ng case number 2. When beta squared is greater than 0. So if this happens, alam natin, okay, m squared is beta squared, m is plus and minus beta, m squared is negative beta squared kasi di ba may negative y? So m equals plus and minus beta I. So in here, madali na to. E to the bx, e to the negative bx. In here, madali. Euler's, C3 cosine by, C4 sine by. Take note, kasi ito galing sa y, siya yung letter y. Galing sa x, puro letter x. Now, i-apply ulit natin yung boundary conditions. Boundary condition number 1, yung x daw yung 0. So, e to the 0 is 1. E to the 0 is 1. So, C1 plus C2 is equal to this. Okay, so for this to be equal to 0, for the product to be 0, okay, C1 plus C2 could be equated to 0. Therefore, I can say that C1 is simply the negative of C2. Okay, e di pagsamahin natin siya, take note of this, guys. Di ba? C1 is simply negative C2. So, pwede kong sabihin na palitan natin na C1 na lang siya. Ito, negative C1, di ba? So, I can factor it out. Pero guys, look at this. Look at the one on the right. Isn't it that the definition e to the x minus e to the negative x all over 2 is the hyperbolic definition, hyperbolic sign? So I can say that e to the x minus e to the negative x all over 2 is hyperbolic sign x. Or e to the x minus e to the negative x is equal to 2 hyperbolic sign of x. Tama? So, eto, ang ginawa ko, e to the bx, e to the negative bx, C1, baka pwede natin siya i-convert into hyperbolic sign. So that one becomes hyperbolic sign x. Pag nagtanong kayo, ay hyperbolic sign of beta x to, sorry. Kinulang ako ng beta, hang on. Beta x. Can you follow, guys? But then, yung 2, pag tinanong nyo, saan napunta? Take note that a constant, C1 multiplied to 2 is simply another constant. Walang problema. So, ayun, sorry, ayun, nagka-beta na. So, in this case, Let's apply the next boundary. As I said, pinakamadali yung may mga zero. So if I apply those with y equals 0, ito, na-simplify ko na. Yung y naman daw yung magzi-0. So cosine of 0 is 1, sine of 0 is 0. So cancel na itong buong to. Mangyayari, C3 times 1, right? So ito yung matitira sa atin. Now, when we multiply this, we can see that if we let C3 be equal to 0, ang mangyayari, if we let C3 be equal to 0, kasi ito, hindi mo natin siniro. Kung itong number na to ang ginawa natin 0, let's look back at number 2. Pwede ko palang i-cancel tong buong to. It can be reduced to C4 sine beta y. Take note, this is a hyperbolic. The others are plain trigonometric. So ito pala matitira. And take note, again, you have C4 and C5, which are products. Ilabas natin, gawin natin C6. Ngayon may tanong ako, meron pa ba tayong ibang boundary conditions? Yes, di ba? AY equals 0. So yung x natin, we can replace that by A. And then, so ito, equate natin to 0. C6, hyperbolic sine BA, sine BY. Okay? Now, in this case, you can see na if we let C6, yung isang constant, be equal to 0, yung bang isa, pwede ba natin maging 0? Ito, take note that the hyperbolic sign can never be equal to 0. Why? Because these ones are exponential. And you know that for exponentials, it never becomes 0. Okay? Tapos, sine of by. Ito, may note ako sa taas. So, sine of by is never 0. Why? Because you know that earlier, y is greater than 0, less than b. So, yun, it will never be 0 kasi it's less than b, but greater than 0. But if it's equal to 0, pwede siguro. Tama? So, in this case pala, kahit paano natin paulit-ulitin din, dahil yung C6 natin, which is this one, yung simplified form na nag-equal sa 0, lagi magiging 0 siya. So this is another one of what you call trivial solution. So maybe pwede tayong pumunta sa third case. In our third case, dito naman tayo mag-less than. Kasi ito, negative of negative. Kasi di ba, take note. If you can recall, y double prime over negative y. Di ba? In this case, negative beta squared. Therefore, y double prime over y is beta squared. Positive na lang siya. Therefore, m squared is plus and minus beta. Yung negative na punta dito sa kabilang side. Okay. Let's just do that. Andito yung Euler. Ito hindi Euler. Okay. Let's apply the boundary conditions. When x is 0, edi 0 to. Cosine of 0 is 1. Sine of 0 is 0. So matitira na lang C1 times 1. This one, walang effect sa kanya. Now, in this case, if we let C1 be 0, let's simplify. Mangyari, pag yung C1 daw 0, maka-cancel. C2 sin bx times the rest. Ayun, no? So we have equation 2. Now that you have equation number 2, guys, let's apply another boundary condition. Boundary condition 3, kasi yun yung may 0 eh. Okay, yung y naman daw yung 0 sa kanya. So, in this case, here, 1, this one becomes 1. So, C3 plus C4. So, with this line, if we let C3 plus C4 equals 0, C3 is negative C4. And then, mapapansin nyo, para lang siyang kanina yung hyperbolic. So, this one, you can say, this is C3 e to the beta y minus e to the negative beta y. So ito magiging 2 sine hyperbolic beta y. However, yung 2 times C3 times C2, ayun no, you can say that that is equal to C5. Okay. Next, yung isang boundary condition. Ito, variable na to. Ito, A. A is any constant that's non-zero. So, if apply natin siya dito, if we let sine beta A be equal to 0, ito siya. Sine beta A equals 0, magiging beta A is equal to arc sine of 0 is equal to n pi. Kasi tuwing kailan ba nagiging 0 yung sine? Di ba at any factors of any multiples of pi where n is equal to 1, 2, 3, and so on. So I can see here that beta is simply n pi all over a. This might be a bit long. So ito, yung beta natin, papalitan na lang natin. Okay, take note, di ba nakatatlong boundary conditions na tayong na-i-apply? But hindi pa natin na-apply yung isa. So the last boundary condition in here is this. Kasi dito guys, look oh, pagka nag-zero siya, di ba you can simplify to this? Eh ito, pag in-equal mo sa 0, hindi naman 0 yung C5. So, kasi dito, look oh, in the other cases, case number 2, walang ibang magzi-zero but then the C6. In this case, hindi lang yung C5 yung pwede mag-zero. Kasi alam natin yung hyperbolic bawal mag-zero. But can sine BA be 0? Yes, it can be. Diba? So, hindi siya naging trivial solution. We can apply another boundary condition. If this is equal to f of x, which is equal to 10, okay, this is what you call the Fourier sine series, guys. I will show you the Fourier sine series, but then I would want you to read on that on your own. So it becomes this. Pag sinabi nyo, sir, ang hirap sagutin, it might look difficult, ito, pero you will end up with this up to here. It might look difficult, however, may form naman kasi siya. Ito, di ba parang ang hirap intindihin up to here? Yes, it might look like that. Pero ito kasi, nagiging summation. Pag sinabi nyo, ano ba yan? Napakahirap intindihin. Yes, but I'll show you something. Okay. So, this is the Fourier series expansion. What is this used for? It's useful in modeling, solve both ordinary and partial differential equations, solve problems in heat flow and vibrations, and to approximate discontinuous periodic functions. So ano yung form niya? Look at this. Diba? Yung kanina. It might look ugly, yes. Ang validity niya from negative C up to C. Pero I will show you two different forms of the formula. Kasi in some books, you will see the one on top. Some, you'll see the one at the bottom. The only difference between them is yung first term. This one is A sub 0 over 2. This one is basically A sub 0. I'll show you the difference. So for Fourier series expansion, kung ito yung form, sabi nga ayan, no, as some sources use A0 only in their fx, note that the multiply in front of the integral in the denominator below is 2c. Ito, as opposed to just c. Kasi di ba, some books, A sub 0 over 2, yung iba naman, pag A sub 0 lang, naglalagay naman sila ng 2 sa ilalim. So it's just the same. Ito, di ba yung A sub 0 ng iba ganito? Pero yung iba, ito yung ginagamit. So it depends. If you use this, maglalagay tayo ng divided by 2. But if you use this, walang over 2 kasi yung A sub 0 natin may 2 na in front. Can you follow what I mean? That if you use the yellow formula as well. If you use the white formula, use the white formula as well. So how are these being applied? For example, ito. Di ba alam natin, ito yung naka-blue na lang siya. Ito yung mas important. That B sub n is equal to 2 over C, etc., etc. Kasi bakit? Di ba ang sabi ko, validity is from negative C to C? So if I place that in the integral, you know na, if this if this functions from negative C to C, gawin na lang natin siyang pag-odd function, di ba? 2 over C, tama? Tapos from 0 to C na lang siya. Kasi odd function naman yung sign. Okay. And then yung A sub n, ganun din. Di ba? So what we can do here is this. Paano raw i-apply yung expansion? For example, yung buong function natin, yung validity niya, from negative pi up to pi. Okay. So that means from negative C to C, from negative pi to pi, that means ang C is equal to pi. So if I were to write the Fourier series expansion from negative pi to pi, 1 over pi in front, and then f of x dx. So i-evaluate natin from negative pi to 0, ito lang siya. From 0 up to pi, ito siya. Hindi pala ako pwede maglagay ng 2 over. Just like ito, may mga 2 over. Sorry. May 2 over c. Bakit hindi ako pwede maglagay ng 2 over c? Kasi magkaiba yung function ko eh. So, evaluate ko na lang sila. So, this one, ito na lang evaluate ko. Pi x minus x squared over 2 from 0 to pi, 1 over pi. So, may value na ako ng a sub 0. That's pi over 2. Kunin natin yung a sub n, di ba? It's just formula naman. A sub n is this. Okay? From negative pi to pi, f of x cosine n pi x over pi. Kasi if you plug in c in the formula, magka-cancel yung pi. Alright. Kasi evaluate natin siya as 0 yung isa. Yung isa naman, pi minus x cosine nx dx. And then, in here, this is a function of x. This is a function of x. It is integration by parts. Ito, I won't go to this anymore. Dapat alam niyo na to, integration by parts. Okay, so you'll end up having this as the formula. Lastly, yung b sub n. Kasi di ba take note, tatlo yun. A sub 0, a sub n, and b sub n. For b sub n, let's use this form. O kaya yung longer form from negative c to c of f of x, etc. You'll end up with this as well, another integration by parts. Okay, pag na-simplify pa natin siya, 1 over n. So when we combine all those, it's simply just the summation. So ito yung pinaka-final answer. Parang it can be simplified into this. Because sometimes you might be asked, okay, give me the first two terms. Hindi ang first two terms mo, pi over 4 plus yung when n is equal to 1, just plug in. When n is equal to 2, plug it in. Okay?